Hi students, welcome to PhD Jobs and Admission. This is Gauri. So in this video, I am going to teach you about research methodology section of PhD entrance test at Anna University. Okay. So in today's session, I am going to teach you about hypothesis testing in research, which is most important part in research methodology, because on these concepts basically you will be asking more MCQs in the PhD entrance test at Anna University every year. So I'm going to teach you this concept by using MCQs. Okay, so after viewing this session you will understand exactly what are the different concepts behind hypothesis testing in research. Okay, but still if you have any doubts you can ask me in the comment box of this video. Okay. So before starting this session, students, I want to tell you that Global Online team provides you complete course on research methodology, because at Anna University there is PhD entrance test for PhD admission, and in that PhD entrance test you will be asking 25% MCQs on research methodology. And that's why if you want to qualify the PhD entrance test, then obviously you need to score more marks in research methodology section itself. And that's why by using this course you can easily score more marks in research methodology and qualify the PhD entrance test. So in this course we provide you full syllabus video lectures under which MCQs and theory lectures are available. You will get full syllabus notes and mock tests. You will get more than 1500 MCQs revision PDF, and all of these study materials are available in both the languages, and those are Hindi and English. So basically we have 10 mock tests like this, and each mock test contains 40 MCQs, and that's why overall you can solve 400 MCQs over here. By the use of this revision PDF, you can revise all the topics in a single PDF, and that's why you will be asking 80% MCQs from this single PDF only out of 100% MCQs in the research methodology section of PhD entrance test. So students, if you want to buy this course, then you can either download the Global Online app from the Play Store. For that I have given the link in the description box of this video, or else you can contact me through these WhatsApp numbers. And the course fees are only 699 rupees, which are really very low. And in these course fees, Global Online team provides you step-by-step guidance at each and every stage of your PhD admission procedure at Anna University, and as well Global Online team provides you 100% passing guarantee that you can guaranteed qualify the PhD entrance test. Okay, so now let us start with our today's session. Now the question 1 is, a paired t-test consists of n pairs of observations. What is the number of degrees of freedom for the test? So here they have given us that there is a paired t-test and it consists of n numbers of observations. Okay, n pairs of observations basically, and we need to find out the number of degrees of freedom. So students, degrees of freedom, this concept is really important in the statistical tests, because through the degrees of freedom only we can find out the results of test statistic. Okay, and degrees of freedom means that, you know, free entities or free pieces of information, okay, of the data, and this is really very much important. So for paired t-test, the formula for degree of freedom is df is equal to n minus 1, where n is the number or pairs of observations, and that's why your correct answer over here should be 3, because the correct answer is n minus 1, which is the formula for degrees of freedom in paired t-test. Next, students, t-test was designed by. Now here they have given the names of different scientists, and we need to find out the name of the scientist who has given or designed a student's t-test. So whether he is R.A. Fisher or Wilcoxon or Wald, Wolfo, Wids or W.S. Gossett. So basically students, this student's t-test, okay, this is referred to as technique for testing theory of mean, okay, for testing theory of mean of small sample which is taken from population with normally distributed distribution, okay, when standard deviation of provided population is unknown. So basically we use this student's t-test whenever the distribution of data within the population is normal, and as well we don't know about the standard deviation of it, and here we need to find out the differences in the mean of the samples. Okay, and this is the technique, and this is basically designed by William Silly Set. Okay, and that's why your correct answer should be for WS Set. And the formula for students t-test is equal to x1 bar minus x2 bar upon under root s square in bracket 1 upon n1 plus 1 upon n2. Okay, so here x1 bar is the mean of sample 1 or group 1, x2 bar is the mean of sample 2 or group 2, s square is the standard deviation value if they have given. Then basically here the actually value of standard deviation is unknown, but here is the formula is like this, and n1 is the total number of samples for group 1 or sample 1, then n2 is the total number of samples for group 2 or sample 2. Okay, all of you getting, students? And there are different types of t-test, such as paired t-test is there, and in the paired t-test groups are drawn from same population. Okay, then two sample t-test, here groups are drawn from two different population, and in one sample t-test group is being compared against only standard value. Okay, but here your correct answer should be 4. Okay, next, which one among the following statement is true in the context of the testing of hypothesis? Okay, so here they have given us different statements regarding the testing of hypothesis part, and we need to find out the true statement which is relevant to the testing of hypothesis concept. So the first statement is, it is only the alternative hypothesis that can be tested. It is only the null hypothesis that can be tested. Both the alternative and the null hypothesis can be tested. Both the alternative and null hypothesis cannot be tested. So students, we formulate hypothesis so that we can test it. Okay, and that's why there is the a permission, or you can say there is a rule, okay, that we need to test the hypothesis in any kind of a research process, and here we only test the null hypothesis. Okay, because whenever we accept the null hypothesis, okay, then in that case we are going to reject the alternative hypothesis, and whenever we reject the null hypothesis, then in that case we are going to accept the alternative hypothesis, and that's why there is need to only test only one hypothesis, and which is null hypothesis. Okay, so this is the most important concept in testing part of hypothesis, because we need to know exactly what type of hypothesis we are going to test, and here is the answer, that is 2, which is we are going to test only null hypothesis. Okay, next, goodness of fit of a distribution is tested by. Now goodness of fit of a distribution is tested by which statistical technique? So whether it is t-test or f-test or chi-square test or z-test. Okay, so students, let us see first of all what is goodness of fit of a distribution. So goodness of fit is basically a test, and this is a statistical technique. Okay, and here we see how well sample data fit a distribution from population with normal distribution exactly. Okay, and there are lots of methods to determine goodness of fit test. So one of them is chi-square test. Okay, chi-square test. Then the another test is Kolmogorov-Smirnov test. Okay, Kolmogorov Smirnov test. Then next is Anderson-Darling test, and next is Shapiro-Wilk test. Okay, so students, you need not to remember all these tests, but only remember the chi-square test over here, because this is the most commonly used test to test for goodness of fit of a distribution. Okay, and that's why here your correct answer should be chi-square test. Okay, now over here T test, F test and Z test. Okay, all of these three tests are the parametric test, and chi-square test is the non-parametric test. Okay, so by using a T test, basically we can find out exactly whether there is a significant difference between the groups or not. Okay, F test basically is based upon the F statistic, and F statistic is nothing but the ratio between two independent chi-square variates, okay, that are divided by their respective degree of freedom. Okay, so here basically F test lets us know exactly the differences between the variances between the two groups. Okay, and Z test is again similar to T test, and by using Z test as well we can find out the means of the differences between the two groups. But over here we know exactly what is the standard deviation of the population. And as well, Z test is a way to figure out if results from test are valid or repeatable. Okay, so it is similar to T test only, and that's why your correct answer over here should be 3, that is chi-square test. Next is arrange the following steps in the process of hypothesis testing in proper sequence. Now over here they have given us the steps of hypothesis testing, and we need to keep an order, or we need to show the proper sequence of these processes of hypothesis testing. So now let us see what are the different steps they have given us. Select the level of significance, then set up null and alternative hypothesis, establish the decision rule, then performance computations, then select test statistics, then draw conclusion. So students, now I am going to tell you exactly the proper sequence of process of hypothesis testing. So your first step should be set up null and alternative hypothesis. Okay, so first of all we need to set up the null and alternative hypothesis. Then your second step should be select significance level. Select significance level. Okay, then third step should be select test statistics. Select test statistics. Okay, then fourth step should be establish decision rule. Establish decision rule. Then fifth is performance computation. Okay, performance computation. Then sixth one is draw conclusion. Okay, draw conclusion. So now whenever you see this sequence, then you will understand that your correct answer should be 4, that is B, A, E, C, D, F, because here set up null and alternative hypothesis is first step, which is your option B. Okay, then after that select the level of significance, which will be your second step, which is option A. Then again select test statistics will be E option. Then establish the decision rule is C option. Then performance computations D option, and draw conclusion F option, and that's why your correct answer should be 4. Okay, next, which among the following are non-parametric statistics? So over here they have given us some names of non-parametric statistics, and we need to identify from this list what are those non-parametric statistics. So T test, F test, Spearman's rank order correlation, Mann-Whitney-Wilcoxon test, or Kindle coefficient of concordance. Okay, so students, as I have told you earlier in the previous videos, that there are basically two types of tests, and those are parametric and non-parametric tests. And parametric tests basically based upon certain assumptions about the population, but non-parametric test does not assume any assumptions regarding the population. Basically non-parametric test follows a distribution free population. Okay, so from these list Spearman's rank order correlation, Mann-Whitney-Wilcoxon test, and Kindle coefficient of concordance. These are the types of non-parametric statistics, and t-test and f-test that I have told you earlier in this video, these are the parametric tests. Okay, so now let us see exactly what are these. So now this Spearman's rank correlation basically assesses how well there is the relationship between two variables can be described by using monotonic function. Monotonic function means by using only single function. Okay, or you can say here whatever we use actually is the rank order. So basically here there is lots of data and we give the ranking to the data, and based upon the ranking we are going to do the testing over here. Okay, and next is Mann-Whitney-Wilcoxon test. This is the alternative test for unpaired t-test. Okay, unpaired t-test is there, which is a parametric test, and if because of certain assumptions we can't able to do this parametric test, then alternatively instead of this we can follow Mann-Whitney-Wilcoxon test. Okay, and the last one is Kindle coefficient of concordance. This is again the test which is non-parametric, and it is used for assessing agreement among raters basically. Okay, and that's why here your correct answer should be 4, that is C, D and E only. Okay, next, kinked demand curve hypothesis was put forward by. So here they have given the names of certain scientists, and we need to identify the name of that scientist who has given the concept of kinked demand curve hypothesis. So let us see different options. Paul M. Sweezy, Augustine Cournot, Bert Rand, then Stackelberg. So first of all, let us see exactly what is the kinked demand curve hypothesis. Okay, so basically this kinked demand curve, okay, this illustrates interdependence of firms in an oligopoly market. Okay, so there is an oligopoly market. Okay, oligopoly market, and here by using this curve we can illustrate the interdependence of firms in this market. Okay, and there is a kink at level of prevailing price. So when there is a level of prevailing price, then at that level there will be a kink. Okay, and there is kink which exists, okay, because there are certain reasons behind it. So what are those reasons? So the first reason is segment above prevailing price level is highly elastic. So when there is a level of prevailing price, okay, so after that price when there is highly elastic behavior, okay, so that's why there is kink. And the second reason is segment below prevailing price level is inelastic. Okay, so there is a segment below prevailing price level and which is inelastic, and because of that there is kink. Okay, but you need to understand over here only the correct answer is Paul M. Sweezy, and this is the scientist who has given the concept of kinked demand curve hypothesis. Okay, next is which test we normally apply for qualitative data. So whenever we need to test the qualitative data, then for that which kind of test we normally apply. So whether it is t-test, whether it is f-test, whether it is chi-square test or z-test. So basically students, when there is a qualitative data which is only in the picture or word format, and whenever we are going to test the qualitative data, then our testing purpose is to understand the human behavior basically, and for testing such kind of data we normally use chi-square test, because chi-square test is the non-parametric test. Okay, this is non-parametric test and it does not based upon certain assumptions, and the other tests over here are t-test, f-test and z-test, and these three tests are the parametric test and they based upon the certain assumptions of the population. And as I have told you earlier in this video that chi-square test can test the goodness of fit, right, goodness of fit. And as well there is another test which can be done by using chi-square test is the independence test. Okay, independence test, and that's why whenever we need to test the qualitative data, then we normally apply chi-square test. Okay, and that's why your correct answer should be 3. Next, F test is used to test the significance of the differences between or among. So what is the usefulness of F test, why we use the F test? So whether we need to identify the significance of the differences between or among two sample mean, or more than two samples mean, or variance of two samples, or B and C. B and C means second and third option. So students, as I have told you earlier in this video, that F test is what? This is the parametric test. Okay, and F test basically based upon the F statistic, and F statistic is nothing but the ratio. So what is this ratio? This is the ratio between two independent chi-square variates. So here two independent chi-square variates. So this is the ratio between two independent chi-square variates, okay, that are divided by their respective degrees of freedom. So basically this is the ratio between, okay, so for example, I have this V1 variate, so divided by its degree of freedom upon second variate divided by its degree of freedom. So this whole ratio is nothing but the F statistic, and that's why F statistic or F test is used to test the significance of the differences between or among variance of two samples. Okay, and as well F test is used by ANOVA. Okay, and ANOVA is the parametric test, and this is the extension of T test. In ANOVA we can assess the means between more than two groups. All of you getting? And that's why whenever I need to test or see whether there is differences among or between more than two samples mean, then again for that purpose as well I can use F test, and that's why your correct answer over here should be 4, that is this B and C, because both of these can be done by using F test. Okay, so students, don't confuse this, don't confuse with this. Okay, you can understand over here that F test is used to test the significance of the differences between or among more than two samples mean, and as well variance of two samples. Okay, next is, now here they have given us two lists, list 1 and list 2, and we need to match list 1 with the list 2. So now let us see over here first of all what is list 2. So in list 2 they have given certain names of the test: Z test, chi-square test, and F test. And here in list 1 they have given the use of these tests, why we use this test. So first option is testing the goodness of fit of a distribution, testing the significance of the differences among the average performance more than two sample groups, testing the significance of the difference between the average performance of two sample groups. Okay, and basically these groups are large sized. So now in this video we have seen that chi-square test can be used to test the goodness of fit of a distribution, right? And that's why A will go for 2. So Z test and F test both are parametric test. Okay, and earlier in the previous question itself we have seen that, okay, whenever I need to test for the differences among the performance of more than two sample groups, then in that case I can use F test, and that's why here B will go for 3, and obviously the remaining option C will go for 1, which is Z test, and that's why your correct answer should be 2 over here. So you can see here A will going for 2, B 3, and C 1. Okay, so this should be your correct answer. Next, so students, thank you for watching this session. I hope all of you understood everything whatever I have told you. And in the hypothesis testing part, the most important thing is that we need to understand exactly why we are testing the hypothesis, why this is important, and as well what type of test we are going to be used whenever we are going to test the hypothesis, because every test has its own goal, every test has its own functions, and that's why there are lots of tests, and I hope I have told you many of them in this video itself. But still, if you have any doubts in that, you can ask me in the comment section of this video.